When running non-metallic sheath cable, often referred to as Romex, in attic spaces, particularly when the run exceeds 10 feet, the elevated temperatures within the attic environment must be taken into account. The primary consideration is the impact of these temperatures on the cable's ampacity, which is the maximum amount of electrical current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. To address this, the most reliable approach involves using a set number or established industry standards to determine the appropriate ampacity derating factor for the specific conditions present in the attic. The National Electrical Code, or NEC, provides detailed guidelines on adjusting conductor ampacity based on varying temperature conditions. Specifically, Section 310.15b3 of the NEC stipulates that the ampacity of conductors must be adjusted when the ambient temperature surpasses 30 degrees Celsius, which is equivalent to 86 degrees Fahrenheit. NEC Table 310.15b3 offers ampacity adjustment factors for various temperatures. This table is crucial for ensuring safe and compliant electrical installations in environments subject to high temperatures. To illustrate, suppose the ambient temperature in the attic space reaches 120 degrees Fahrenheit or approximately 49 degrees Celsius. According to NEC Table 310.15b3, the ampacity of a 14 American wire gauge, or OG, Romex cable would need to be derated by 20%. This derating means that a 14 AWG Romex cable, typically rated for 15 amps at 30 degrees Celsius, would only be safely able to carry 12 amps at 120 degrees Fahrenheit. This reduction in ampacity is essential to prevent the cable from overheating, which can lead to insulation damage, electrical arcing, and potential fire hazards. Using industry standards such as the NEC or a predetermined set number to calculate the ampacity derating factor is of utmost importance for several reasons. Firstly, it ensures that the Romex cable is not overloaded, which could cause the cable to overheat and potentially ignite surrounding materials. Secondly, it mitigates the risk of electrical fires, which can result in significant property damage and endanger lives. Thirdly, it ensures compliance with electrical codes and regulations, which are designed to promote safe electrical practices and protect individuals and property from electrical hazards. Guessing the temperature or estimating how hot the attic might become on a given day is not a reliable or acceptable method for determining the ampacity derating factor. Temperature fluctuations within an attic can vary significantly based on factors such as the time of day, weather conditions, insulation levels, and ventilation. Relying on guesswork could lead to inaccurate derating calculations, potentially resulting in an underestimation of the required ampacity and increasing the risk of overheating and fire. Furthermore, it is essential to be aware that Romex cable should not be installed in areas where the ambient temperature is likely to exceed 140 degrees Fahrenheit, which is approximately 60 degrees Celsius. Exceeding this temperature limit can cause the cable's insulation to degrade rapidly, compromising its integrity and increasing the risk of electrical hazards. In situations where the ambient temperature is expected to exceed 140 degrees Fahrenheit, alternative wiring methods, such as using conductors with higher temperature ratings or employing conduit for protection, should be considered. In summary, when installing Romex cable in attic spaces, particularly for runs exceeding 10 feet, it is crucial to account for the impact of temperature on the cable's ampacity. Using industry standards such as the NEC and employing appropriate derating factors based on the expected ambient temperature are essential for ensuring safe and compliant electrical installations. Guessing or estimating temperatures is not a reliable approach, and alternative wiring methods should be considered for environments where temperatures are likely to exceed the cable's temperature rating. The NEC provides specific tables and guidelines for derating conductors in high-temperature environments. These guidelines are based on extensive testing and research to ensure the safety and reliability of electrical systems. To accurately determine the ampacity derating factor, firstly, measure or estimate the maximum ambient temperature in the attic space. This can be done using a thermometer or by consulting historical temperature data for the region. Secondly, consult NEC Table 310.15b3 to find the ampacity adjustment factor that corresponds to the measured or estimated ambient temperature. Thirdly, multiply the cable's rated ampacity by the adjustment factor to determine the derated ampacity. For example, if a 14 AWG Romex cable is rated for 15 amps and the adjustment factor for the attic temperature is 0.8, the derated ampacity would be 15 amps multiplied by 0.8, which equals 12 amps. Fourthly, ensure that the derated ampacity is sufficient to handle the expected load in the circuit. If the load exceeds the derated ampacity, either increase the wire gauge or reduce the load. In addition to temperature derating, it is also important to consider other factors that can affect the ampacity of Romex cable in attic spaces. These factors include the number of conductors in a raceway or cable, the presence of thermal insulation, and the proximity to other heat sources. The NEC provides additional guidelines for derating conductors based on these factors. For example, if multiple conductors are bundled together in a cable or raceway, the ampacity of each conductor must be derated to account for the increased heat generated by the group. Similarly, if Romex cable is installed in direct contact with thermal insulation, its ampacity must be derated to prevent overheating. Furthermore, it is important to ensure that Romex cable is properly supported and protected from physical damage in attic spaces. The cable should be secured to framing members at regular intervals using cable ties or staples. It should also be protected from sharp edges or other objects that could damage the insulation. In addition to the NEC, other industry standards and best practices can provide valuable guidance on installing Romex cable in attic spaces. These resources may offer additional insights into temperature derating, conductor sizing, and cable protection. Consulting with a qualified electrician can also be beneficial, as they can assess the specific conditions in the attic and recommend the most appropriate wiring methods and materials. When working with electrical systems, safety should always be the top priority. Before beginning any electrical work, ensure that the power to the circuit is turned off at the breaker panel. Use appropriate personal protective equipment such as safety glasses and gloves to protect yourself from electrical hazards. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. In summary, properly accounting for temperature when running Romex cable in attic spaces is crucial for ensuring safe and reliable electrical installations. By using industry standards such as the NEC and employing appropriate derating factors, you can prevent overheating, reduce the risk of fire, and comply with electrical codes and regulations. Remember to consider all factors that could affect the ampacity of the cable, including temperature, conductor bundling, insulation, and physical protection. When in doubt, consult with a qualified electrician to ensure that the work is performed safely and correctly. The NEC also provides guidance on the proper installation of Romex cable in various locations, including attics. These guidelines cover topics such as cable support, protection from physical damage, and clearance from heat sources. Adhering to these guidelines can further enhance the safety and reliability of the electrical installation. For example, the NEC specifies that Romex cable must be supported at intervals not exceeding 4.5 feet and within 12 inches of boxes, cabinets, and fittings. This support helps to prevent the cable from sagging or becoming damaged over time. The NEC also requires that Romex cable be protected from physical damage where it is exposed to abrasion or impact. This protection can be achieved by installing the cable in conduit or by using a cable guard. In addition to the NEC, local electrical codes may also have specific requirements for installing Romex cable in attic spaces. These local codes may be more stringent than the NEC and should be followed to ensure compliance. Before beginning any electrical work, it is important to obtain the necessary permits from the local authorities. These permits help to ensure that the work is performed safely and in accordance with applicable codes and regulations. The permitting process may also involve inspections by electrical inspectors who can verify that the installation meets the required standards. When selecting Romex cable for use in attic spaces, it is important to choose a cable with the appropriate temperature rating for the expected ambient temperature. Romex cable is typically available with temperature ratings of 60 degrees Celsius, 75 degrees Celsius, and 90 degrees Celsius. The higher the temperature rating, the more resistant the cable is to heat degradation. In attic spaces where the ambient temperature is expected to exceed 60 degrees Celsius, it is recommended to use a Romex cable with a temperature rating of 75 degrees Celsius or 90 degrees Celsius. Furthermore, it is important to consider the type of insulation used in the Romex cable. Romex cable is typically available with either thermoplastic high heat resistant nylon or THHN or cross-linked polyethylene or XLPE insulation. THHN insulation is a common choice for general-purpose wiring, while XLPE insulation offers superior heat resistance and is often preferred for high-temperature applications. In attic spaces where the ambient temperature is expected to be high, XLPE insulated Romex cable may be a better choice than THHN insulated cable. In addition to temperature and insulation, it is also important to consider the size and type of conductors used in the Romex cable. The size of the conductors should be sufficient to carry the expected load in the circuit, taking into account any applicable ampacity derating factors. The type of conductors used in the Romex cable can also affect its performance in high-temperature environments. Copper conductors are generally preferred over aluminum conductors due to their superior conductivity and heat resistance. When connecting Romex cable to electrical devices such as outlets and switches, it is important to use the proper wiring techniques and connectors. The connection should be tight and secure to prevent overheating and arcing. The connectors should be rated for the size and type of conductors used in the Romex cable. Furthermore, it is important to properly ground the electrical system to protect against electrical shock hazards. The grounding system should be installed in accordance with the NEC and local electrical codes. The grounding conductor should be connected to the metal enclosures of electrical devices and to the grounding electrode system of the building. In summary, installing Romex cable in attic spaces requires careful planning and attention to detail to ensure safety and compliance with electrical codes and regulations. By considering factors such as temperature, ampacity, insulation, conductor size, wiring techniques, and grounding, you can create a safe and reliable electrical system that will provide years of trouble-free service. Remember to always prioritize safety and consult with a qualified electrician if you have any questions or concerns. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice.